Okay, today's lesson is on dividing algebraic fractions, and for our guest stars today we have Sylvester and a little bit of Tweety showing up to help us through this. When we do dividing fractions, you're going to find it's very much like multiplying fractions. You're going to remember stay, change, flip, okay? The stay part means that the first fraction stays the same. Change, you're going to change the division to multiplication. And the flip, because we're going to use the reciprocal, we're going to flip the second fraction. Once you do that, once you do same, change, flip, everything for dividing fractions becomes multiplying fractions. So you're going to factor each numerator, you're going to factor each denominator, you're going to have a good time canceling everything you can, and then you multiply straight across. Okay, so here we go. First example, just numeric example, no algebra involved here. You copy the first fraction over, change division to multiplication, and flip the second fraction. Now, if you can cancel at this moment without factoring, then go right ahead. I'm going to factor 9 to be 3 times 3, 10 to be 2 times 5, and 4 to be 2 times 2. And once I factor them, I like to cross them out like that so I don't get confused that those numbers are still there. Once we factor, we can cancel a like factor in the numerator with a like factor in the denominator. So the 2 and the 2 will go. And I'm pretty sure that's all that's left. So I have a 5, 2, and 3. So multiplying straight across. Remember, if everything cancels, it's a 1. So I have 1 times 5, which is 5, and 2 times 3, which is 6. So our answer will be 5/6. And it really is that easy. Okay, our first algebra one, we're going to do same, change, flip. The first fraction stays the same. We change the division sign to multiplication, and we flip the second fraction. Okay, next step after same, change, flip is factor each numerator. Well, 3 doesn't factor because it's a prime, so we're going to leave 3 as 3. 12, however, I can write as 3 times 4, but then 4 can go down as to 2 times 2. So I'm going to break 12 down into 3 times 2 times 2. And you just want to check it. 3 times 2 is 6, times 2 is 12. Okay? X plus 2, that's a binomial, but there's nothing in common. The x and the 2 don't have any factors in common, and it's not squared, so I can't use reverse FOIL. So that's done. In this numerator, 2x plus 4, again, there's no quadratic, there's no x squared, so I'm not going with the double parentheses or anything like that. I'm just taking out a common factor of 2. Now, if I take out a 2, this first term, 2 times x, I have an x. If I divide out a 2 from 4, I'm left with 2. Check it. 2x, 2 times x is 2x. 2 times 2 is 4. So this checks. I factored it. We're all set. Now comes the fun part. You get to cancel everything, any factors that are repeating in the numerator and denominator. This 2 can take out this 2 because one's in a numerator, one's in a denominator. They can be in the same fraction, just one has to be a numerator, one has to be a denominator. The entire parenthesis, x plus 2, can take out the entire denominator, x plus 2. This 3 down here can take out that 3 up there. Notice everything in the numerator now is gone. It's all been crossed out. 2 went into 2 once. 3 went into 3 once. X plus 2 went into x plus 2 once. 1 times 1 times 1. When everything cancels out, it's a 1. Here, I just have a 2 left over. Isn't that beautiful? We have this, algebraic division problem with algebraic fractions, and the answer comes out to be a little sweet 1/2. It doesn't get much better than this. Okay, last example. We're going to copy that monster, that first fraction over. 2x cubed plus 10x squared plus 8x over x squared plus 2x minus 8. Now, that's the same. Now we change. Division, multiplication. Now we flip. Instead of 2x in the numerator, 2x in the denominator, x squared plus, or x squared minus 1 in the numerator. So, same, change, flip, done. Next step, factor. Okay, 2x, monomial, doesn't factor, leave it. X squared minus 1. Love this because that's my fave. Difference between two squares is going to be x and x. 1 and 1. Signs are different. Plus 1 minus 1. Done. Okay? Come down here. X squared plus 2x minus 8. Well, there's nothing in common, and I have a squared, so must be reverse FOIL. Need an x and an x. The numbers have to multiply to give me 8. So multiply to give me 8, 1 and 8, 2 and 4. They have to subtract, because of that minus, to give me 2. So I know now I want 2 and 4. Because of this negative, the signs are different. Larger one's positive. So plus 4 minus 2. Check it. X times x, x squared. That's good. X times 4, positive 4x, minus 2x will give me that positive 2x I want, and then I do get the negative 8. Now, this last numerator, I saved the best for last, you know it. How do you factor something with a cube? Well, the fact of the matter is you don't unless you pull something out. And if you look carefully, each term here has an x. And each term has a 2 in it. So we're going to take a 2x out front. Okay? Now, if I divide a 2x out of that 2x cubed, I'm going to be left with an x squared. And notice if I multiply 2x times x squared, I do get 2x to the third. Okay? 2x into 10x squared. Well, 2 goes into 10. 5. X would take out one of the x's, so I'll be left with just x instead of x squared. 2 goes into 8 4 times, and the x's would cancel each other out. Check it. 2x cubed, multiply, I get 10x squared, multiply, I get 8x. Okay, so I can get rid of this then. Now, I have more work to do because x squared plus 5x plus 4 factors. Okay, the 2x stays where it is. I'm going to use reverse FOIL, x and x. I need two factors that multiply to give me 4 and add to give me 5. So that'll be 1 and 4. The signs are the same and they're both positive. So now that's factored. And I'm pretty sure that's as far as we can factor. Now look, we're heading for common factors. Look at this. 2x. 2x. Bingo. Cross them out. They cancel. X plus 4, a full set of parentheses. X plus 4, gone. They cancel. Okay? Now, you may see this x plus 1 and this x plus 1. Don't get too crazy here. They do not cancel. And they don't cancel because they're both in the numerator. Remember, in order to cancel, one factor has to be in the numerator and one has to be in the denominator. Okay to be in the same fraction, but one's got to be in the numerator and one's got to be in the denominator. And this is what I'm left with, everything that didn't cancel. I might want to tidy that up a bit because I could write x plus 1 times x plus 1 as x plus 1 quantity squared, x minus 1. And that's a nice little answer there. Nothing wrong with that. That's how you divide fractions.